Recently, I came across this video. According to this one, Saudi Arabia is cultivating their wheat in perfect circles like this. So I also searched in Google. So I found the similar pattern. So these are the uh, agricultural land in Saudi Arabia. They are growing wheat in desert. So they are relatively large, and they are using the underground water to cultivate these crops. Now, I'm curious to know what is the temporal pattern of these agricultural land. According to this video, so they said that some of the agricultural land get desertified again after a few cultivation. I want to see what is the aerial extent of these agricultural land in Saudi Arabia. Are they growing or are they decreasing over time? So in order to do that, I'm going to use the Google Earth engine, and then I'm going to follow these 8 steps. So simply, I'm going to first import Landsat imagery and create area of interest, and then generate the year list and filter those images, remove cloud, and compute NDVI and threshold by zero point 0.2. Value greater than zero point 0.2 is the agricultural land or the vegetated land, and I also visualize it, and I compute the area, and I'll write the same code to compute the NDVI and then calculate the area for all the years, and then I'll show you the chart. At the end, you will get some sort of this kind of graph. So in the y-axis you will have vegetation area, and then in the x-axis you have years, and this graph show you the how the agricultural land decrease or increase over time in Saudi Arabia in my area of interest. So yeah, basically this methodology can be used in any other area of the world. Simply you just need to like replace your AOI boundary by your own AOI or the administrative boundary. So let's get start. All right, so the first step is to create area of interest and import Landsat imagery. So if you have any polygon, feel free to upload that in uh, assets, and then simply import that asset. But for now, I'm thinking to create the polygon somewhere here. Okay, let me, maybe I can change the satellite imagery map, and then here I can see these things, right? So these are the cultivation area, right? So I'm trying to compute the area of, but I'm interested in particularly this section, so that's why I create the polygon, and then maybe I'll create the polygon something like this. What happened? Okay, like this. So simply click it, and maybe I'll ignore that and just okay. So this is my area of interest. So in this area, I'm going to compute that, right? After you complete the drawing section, you will get the geometry. Simply change it to the AOI. And now our next step is to import the Landsat imagery, right? So here I'm going to use the Landsat image from Landsat 4 to Landsat 9, right? So let's search for Landsat 4 first. Sorry, Landsat 4, and then which image I would like to use is level 2 collection 2 entire one. So according to this one, so it's atmospherically corrected and then ready to use for the analysis. So it's available from 1982 to 1993, right? So simply I'm going to import it, and then I'll write Landsat 4, and similarly I'll search for Landsat 5, and I'll also choose the level 2 collection 2 entire one image, and then write Landsat 5, and similarly for Landsat 6 collection to, or maybe I can simply search like this. Oh, there are lot. Okay. uh oh, sorry. The We cannot use the Landsat 6 because uh, the mission was not succeed. So maybe Landsat 7. Okay, collection 2, level 2, entire 1, and then simply write Landsat 7, and now Landsat 8, collection 2, type. Okay, this one, Landsat 8, and now Landsat 9. Okay, so if you see it here, so all my imagery are level 2, collection 2, entire 1. So the first step is already completed, right? So the now in next step we are going to generate the dynamic year list from 1984 to the current year, or 1982 maybe, because the Lancet 4 is available from 1982. In order to do that, so my start year is our start year is 1984, and then my current year is 2024, right? Now the year list will be the ee dot list dot sequence, and then from start year to end year, or the current year, right? So if I print the year list, so you will see, sorry, it's, you will see all the years, right? This is the all the years, right? So yeah, the another thing I would like to do is, I'll simply, for now, simply toggle off the geometry. And then also the another thing is, I want to center my map to AOI, and then zoom it in zoom level 10. So in order to do that, I'll simply write map dot center object, CEN center object, and then it's AOI, and then zoom level 10. So if I run it, so it will automatically zoom to my AOI, right? And then here we are seeing the year list. That's great, right? So now let's move to the step 3. So for step 3, I'm going to write, copy and paste few code, and then try to explain that. All right, so I already copy and pasted the code. So here what we are doing is, I write the function to filter the column. So basically it will filter based on date. This call is, can be our imagery, and then we filter based on date, and in the input field this date, we need to pass the array of starting point and end point, and then we filter the bounds. That means we try to filter all the imagery that are touched with area of interest, right? And here in the Landsat 457, these share the almost similar characteristic. That's why we are writing this function. And then here in the call property, so we are filtering the Landsat 4 imagery, and then merging it to Landsat 5 and merging it to Landsat 7. So so the uh, idea here is to like merge these imagery, and then get the composite band from all the merged imagery, right? So that the spectral reflectance value of all these four, we are taking the median one, so that we are simply like trying to improve and then fill the gap if there is any gap in imagery. So basically, yeah, don't worry about this cloud max tm, so I'll write that function as well. So simply it will try to max out the cloud, and we take the mean and then we clip to area of interest and return imagery, right? And here in the Landsat 8 and 9 also, we simply download Landsat 8 and Landsat 9 imagery and then merge them together. And after that we max the cloud. So we have these two functions, don't worry about those. I'm going to explain in the later step, in this step 4. And then we are taking the median value and then we are clipping to area of interest, and both of these functions return the image, right? So yeah. All right, so in order to remove the cloud, so I have cloud max tm function and then cloud max oil function. Basically these will try to like remove the cloudy area from the pixels, right? So here we are selecting that image with the qa pixel. So for example, if I search for Landsat 5 and then go to the properties bands, and you will see qa pixels somewhere here. Okay, let me zoom out. Okay, this one, right? qa pixel, right? So these values here we have like bit values. For example, 1 is diluted cloud, 2 is unused, 3 is cloud, and 4 is cloud shadow, right? We are going to remove these based on bitwise operation, right? So basically if the value is 1, this is diluted. If the value is 3, this is cloud, and then 4 value is shadow, right? We are going to max it based on our, we select that band and then we are going to max it, and then we are going to remove return the bands called SR1 2 3. These are RGB, maybe this is NIR and SWIR 1 and 2, and then rewrite it is B2 3 4 5 6 7, because in the Landsat 8 and 9, so we have this band 2 3 4 represent RGB, so we are trying to match those with the above one, right? And then we are selecting, simply updating max and then returning that imagery. And then here in the cloud max oil also, so for the Landsat 8 and 9 imagery we do the same, we max out and then we return the same band. So basically here dot select function, it's renaming the band name in order to match with the above one, right? So yeah, that's all. So now the other step is to compute the NDVI and threshold by 0.2 and visualize. For this particular section we can take the year equal to maybe I'll write var year equal to maybe 2010, and then I'm going to compute the NDVI and then threshold NDVI for 2010 and threshold by 0.2 and then visualize it. All right, so now here I'm going to compute NDVI and then create the binary max. So in order to do that, so I select 2010 imagery, 2010 year, feel free to select any year, and then here I selected the Landsat 457 because before 2014 imagery were either 4 5 and 7, because Landsat 8 was launched in 2013 at the, I think around 2014. So that's why I am selecting this Landsat 457. And according to this one, so we need to pass the AOI and date, right? So here I'm passing the AOI and our date is array, right? Year starting from August 1 to December, I mean it's 30, and then I'm adding that image to the map. So basically we can see down here, and then I compute the NDVI. Is we all know like the NDVI formula is NIR minus rate by NIR plus rate, right? So simply I compute the NDVI and then I added that to the map. So we know NDVI value ranges from -1 to 1. That's why its minimum maximum value is given. And palette will be blue, white, and green. Basically, green surface means a maximum value. That means we have the like vegetated area in those green spot, right? And then we create the binary max. Simply if the NDVI value is greater than 0.2, that's vegetation, and we name it vegetation, and then we added that layer to the map. And we also compute the pixel area, right? Binary vegetation dot multiply. Simply we are multiplying that with the image pixel area. And here in the area calculation, so simply we calculate the pixel area, and then we use reduce region function. So basically it will try to like compute the area of whole region, whole area of interest, right? And then this scale is our pixel resolution, right? And then here we again compute the area in square kilometer square. So simply we divide by 10 to power 6, right? And then vegetated area will on that particular year will be this one, right? So if I run this, you can see the vegetation area is computing, right? And then we'll get some vegetation area, and after that I'll show you the map. So maybe it will take some time to compute. Basically, okay, it's 218 square kilometer almost. First of all, let's go one by one from Landsat, right? So this is the Landsat imagery from that particular year 2010. So basically if we visualize it in 5 4 or 5 3 and 2 composite band, and then stretch by 98%. So basically in this image, the red reflectance value will be from NIR band, right? So basically this red spot is the vegetated area, and when I check the NDVI value, so basically those red spot will be replaced by the green area. So basically these are the like agricultural land, right? So after that, simply based on thresholding, so we get those polygons, or we get those like circles, right? So this all represent the agricultural land in our area of interest. So the method is quite simple. So for example, if you want to compute it for let's say 2020, then you just need to change this to Landsat 8 or 9. Sorry, do we have that function 8 9, Landsat 8 9, right? Landsat 8 9, and then this also to 2020. So simply run it, and now we'll get the vegetated area in 2020, right? So this is our binary raster over here, right? And if I check the area, so it's 221 square kilometer. So yeah, this way we can generate the area, vegetation area, for only one single year, right? But now I want to somehow like write a loop to compute the NDVI, and then create the graph, which is something similar to this one, right? So in order to do that, so basically I'm in step 7 because I already computed the area over here. Okay, now I'm in step 7. So let me copy and paste the code. All right, so here is the code. Basically, I'm writing the loop, iterate over year list. So this map function will iterate over each year, and then it will take the year as EE number, right? And then here in the image section, so we are checking if the year is less than 2014, we use Landsat 457. band, and then we pass that AOI and then our dates, right? And here in the date I am writing from August 1 to December 31, but feel free to change this date based on your cultivation year, month of the year, right? And here in the if the year is greater than or equal to 2014, then we are going to use Landsat 8 and 9 imagery, right? And here we are ensuring its image, and then it has band. So basically, if it has band, then we'll get something like true, because we are iterating over band name dot size and dot gt 0 greater than 0. That means sometime whenever we try to filter the imagery based on our area of interest and then filter based on cloud, sometime we might miss the image from one full year, right? That's why I'm checking whether the image is empty or not. And if the empty if the image is not empty, then I compute the NDVI as I explained before, so based on band 5 and 4. And then I if there is no band, then I simply return null value. But here if the image is available, then I compute again binary vegetation area based on 0 greater than 0.2 value, and then compute the area as similar to above. And then I convert that area to square kilometer, and then I return that EE feature, right? Else, if there is no image found, then I simply submit null value, and then in the year I return year, but my area will be 0, right? In the visualization part, we can exclude this 0 value. Okay. Oh, sorry, we can exclude that over here as well. So basically we are again filtering that feature collection that collect all the year and area value, and simply we are filtering if the area is greater than 0, then we are only considering that area, that year, right? So yeah, that's all about like area calculation. So the final step is to like generate the chart, time series chart, right? And in order to do that, so simply we can use UI.chart feature from like Google Earth Engine, and then we are going to like generate the chart based on feature, and then we use this filtered feature collection value, and then we simply set the option to the vegetated area over year, and then in the x-axis or the horizontal axis we have year, vertical axis vegetated area square kilometer, and then these are simply line width and point size, right? And if we run it, so it might take some time to like generate the graph, because it's computing huge amount of images from like 1984 to the present date, which is 2024. So yeah, it might take several like 1 to 2 minutes to generate that figure, and once it's generated, I'll show you how it looks like. All right, so this is the graph. So we can open it in the full window by clicking that button, and seems like there is very less vegetation area before like 1988, and then after that year it start growing slightly, and then from like year 2015 it start decreasing with rapid decrease value in from like 2018 to 2020. So yeah, this is the graph, vegetated area graph. Simply I think this is representing the cultivation area in Saudi Arabia, but feel free to generate similar kind of graph for your particular area of interest. So yeah, I hope you like this video. If you like this video, hit the like button and subscribe to my channel. Thank you for watching.